A vehicle of mass 300 kg moves from right to left with a velocity of 10 meter per second, and it comes to rest after traveling a distance of 7.5 meter. CG is the CG of the vehicle acts at a distance of 1.2 meter from the floor from the road. MA is the inertial force acting in the opposite direction to the motion of the vehicle. W is the weight of the vehicle acting downward. NA and NB are the normal reaction at the front and rear axle respectively, and FA is the friction force between the tire and the road at the front, and FB is the friction force between the tire and the road at the rear. We need to find NA, NB, FA and FB. Now V square is equal to U square plus 2AS. Here final velocity is 0, initial velocity is 10 meters 10 squared plus 2 into A into 7.5. Therefore A is minus 6.67 meter per second square. Since the vehicle decelerates, this is the deceleration of the vehicle and hence its negative sign. Inertia force M into A is equal to 3000 into 6.67 is equal to 2010 Newton is equal to 20.1 kilonewton. Force acts opposite to the direction of motion of the vehicle, and W is equal to M into G is equal to 3000 into 9.81 is equal to 29.43 kilonewton. Now summing vertical force is equal to 0 implies W is equal to NA plus NB is equal to 29.43 Newton. Sum of equating the vertical force, W act downwards, second NA and NB act vertically upwards, and summing the horizontal force component is equal to 0 implies FA and FB act towards left, FA plus FB is equal to inertia force act towards right, MA is equal to 20.1 kilonewton. FA and FB can be written as mu into NA plus mu into NB is equal to 20.1 kilonewton. Mu into NA plus NB is equal to 20.1 kilonewton. Therefore, we know the value of NA plus NB is equal to 29.43. Substituting this equation gives coefficient of friction is equal to 0.68. Now, taking moment above this point gives NB into 4 is it acts counterclockwise direction minus inertia force M into A into 1.2, this will act counterclockwise direction minus M into G into 1.6, and this moment will act in the clockwise direction is equal to 0. Therefore NB is equal to 20.1 into 1.2 minus sorry, this will go towards right and this will go towards right, the plus, it will become plus 29.43 into 1.6 divided by 4 is equal to 17.8 kilonewton normal reaction B. Therefore the normal reaction at the rear is 17.80 kilonewton and Na is 11.63 kilonewton. Substituting Nb in the vertical force components, we will be able to get Na. This is the normal reaction at the front. Further, the normal reaction on each wheel, each of the rear wheel is Nb by 2 is equal to 17.80 divided by 2 is equal to 8.90 kilonewton, and normal reaction at each of the front wheel is Na by 2 is equal to 11.63 by 2 is equal to 5.82 kilonewton. Now friction force at the front Fa is equal to mu into Na is equal to 0.68 into Na is 11.63 is equal to 7.90 kilonewton. Further, friction force at each of the wheel is Fa by 2 is equal to 7.90 divided by 2 is equal to 3.95 kilonewton, and friction force at the rear is Fb is equal to mu into Nb is equal to 0.68, Nb is 8.90. Nb is 17.80 is equal to 12.10 kilonewton, and friction force at each of the rear wheel is equal to Fp by 2 is equal to 12.10 divided by 2 is equal to 6.05 kilonewton. Therefore, normal reaction at the front axle is Na is 11.63 kilonewton. Normal reaction at the rear axle is Nb is equal to 17.8 kilonewton, and normal reaction at each of the rear wheel is 8.90 kilonewton. Normal reaction at each of the front wheel is 5.82 kilonewton. Thank you. If you like this knowledge sharing, please subscribe to have further technical discussion.